The way that GSI works is that it's a collection of indicator functions. An indicator function just goes from 0 to 1. This is mathematically very important because even though it's simple, a value of 0, if you multiply 0 times any other value, you get 0. A value of 1, you multiply any other value and you get that value. So what we do is we define limits that say below a certain level, this particular variable is fully constraining plant function. So in this case, minimum temperature. When minimum temperature is below -2 degrees Celsius, which is somewhere around 28 degrees Fahrenheit, plants are completely unhappy. And as you increase above freezing, at some point temperature isn't limiting anymore. So in this case, as we get above 5 degrees Celsius, we assume that minimum temperature doesn't limit plant function any further. So the same works for photoperiod, that we know that through an examination of the literature that plants really respond in a range of about 11 to 12 hours for photoperiod. But below 10 hours is just not enough light for plants to be happy. So any photoperiod below 10 hours would get an indicator value of 0, and any photoperiod above above 11 hours would get an indicator value of 1. And if you're in between 10 and 11, you get some proportion of value between 0 and 1. So 0.5 is halfway. So in this case, if you are at a photoperiod of 10.5 hours, 10 and a half hours, you'd get an indicator function value of 0.5. So we'll save that for for an example in a minute. But vapor pressure deficit's the only one that works in the opposite direction. Low vapor pressure deficits indicate a humid atmosphere, and high vapor pressure deficits indicate a dry atmosphere. So when we're below VPD of 900, we assume that a wet atmosphere means wet soils, and plants are very happy. As that VPD increases to 4100 pascals, once you get to that or exceed that, plants are fully constrained by water availability. So let's just do an example from this. And essentially, if we say that on a given day the minimum temperature was -3, and these are in Celsius, but they're easily converted. The photoperiod was, let's just say it was 11 hours. And the vapor pressure deficit was 800 pascals. If we look at how these functions work, we would say that we put this -3 into this function, and -3 is down here, which is below -2, which gives this indicator a functional value of 0. And even though our photoperiod is at 11, which would give this value 1.0, and a vapor pressure deficit indicator that was right here, which would give it a value of 1.0 as well. GSI is just calculated as the product or the multiplication of these three indicators. So in this case, it's 0 times 1 times 1, which is 0. In that respect, any time any one of these functions is below its lower limit or set to to an indicator value of 0, you get a GSI of 0. The only way that you get a GSI of 1 is for all 3 of these constraints to be met. So if we keep the same example and we raise the temperature from -3 to 6, we can have a different example. So in this case, if the minimum temperature was 6, we go up here and we say that indicator function for now is 1.0, and the photo period was still 11, and the indicator value was 1.0, and the vapor pressure deficit was 800, which makes the indicator value 1.0. And if we multiply 1 times 1 times 1, we get a GSI of 1. Essentially, that's how this works, is that the only way you get a GSI of 1 is for minimum temperature to be high enough, photo period to be long enough, and vapor pressure deficit to be low enough to yield the conditions that make for happy plants.